All right, here's the topics we're going to cover. Consecutive numbers, areas and shapes, similar triangles, mixture of money, distance, rate, and time, work problems, and then just tougher problems. So we're going to start with consecutive numbers. And your consecutive numbers are x, x plus 1, and x plus 2, so on and so forth. It should say consecutive integers. Consecutive numbers really doesn't seem to make sense, but consecutive integers, x, x plus 1, x plus 2. So that means if x was 10, then your consecutive integers would be 10, 11, and 12, because you just add, 1 and 2. What can you do to a number to make it even? Which one? Add 1 or add 2? Well, if it's already even, then it becomes odd. What did you say, Sam? Double it, multiply by 2. So 2x, I promise that if you put in an integer, multiplying by 2 will make it even. All right, so if 2x was the first even integer, what would be the next one after it? 2x plus 2. What will be the one after that? 2x plus 4. Making something odd isn't that difficult once I can make it even. Suppose I have an even number. What do I do to it to make it odd? Add or subtract an odd number. So plus 1. What will be the one after that? 2x plus 3. One after that, 2x plus 5. Excellent. So you got an idea for consecutive numbers, consecutive evens, consecutive odds. Let's try a problem. Find 4 consecutive odd integers whose sum is 80. So, question. Okay, but on the test, you have to model it this way. Because as soon as I give you a question like this, I can always create one that's more difficult. Did you guess and check or did you set it up? Don't guess and check. I will not give you the credit. So make sure you set it up like this. 2x plus 1. Because again, I want to get you to be able to do more difficult problems. And you have to see the setup if you want to do the tough ones. Because I guarantee some of the problems we're going to do, you can't just guess and check. So make sure you set it up. 2x plus 3. I need 4 of them. So 2x plus and plus 2x plus 7 equals 80. Awesome. So those are my odd integers. Okay. How many x's? 8 x's. 1 plus 3 plus 5 plus 7. 16 is equal to 80. Subtract 16. X is 8. Is that my answer? No, 8's not an odd integer. It makes no sense right now. So what I need to do is I need to take that 8 and plug it back in. What is 8 times 2 plus 1? So 17. 8 times 2 plus 3. 19. And you got the idea what's going to happen. Those are my consecutive odd integers whose sum is 80. Now, my guess is that what Parker did is he said 80. Well, all I'm going to do is just divide it by 4, and I got 20. 20 is the middle. So I'll split it in 2. I got 19 and 21, and we'll go down, 2 more and up 2 more, right? Yep. And there's nothing wrong with that. And if you see, Parker, you did similar to what we did, okay? There's a similar method, only you do have to model it because you're going to get other problems that are a little bit more difficult. All right, second one. Find 2 consecutive squares whose sum is 613. Give me an example of 2 consecutive squares. What are 2 consecutive ones? 4 and 9. 225 and 269. Nope. 225 and 256. 169 and 196. So that's okay. It's all right. So these 2 consecutive squares whose sum is 613. So, oh no. Megan, what do you want? Okay, pause. Okay, so we got to be careful here, okay? Because 4 and 9, that would be, how do you represent those as numbers? Well, really, it's 2 squared plus 3 squared, right? 2 squared and 3 squared make consecutive squares. So we will write it as x squared, and then the next one would be, does anybody know? X plus 1 quantity squared. A lot of people write x squared plus 1. and they sum to 613. What is x plus 1 squared FOIL out to? Very good. X squared plus 2x plus 1 equals 613. I have a quadratic. How do you solve quadratics? Gather everything on one side. We got 2x squared plus 2x. I'm going to subtract the 613 over, get minus 612. So that equals 0. Factor, CTS, or QF, quadratic formula. Those are your options. You got to choose which one to do. And on your assignment, you're required to be able to do quadratic formula as well as factor. So what can you take out? Two numbers multiply 306 that add to 1. So they're going to be pretty close together if they add to 1, right? So let's see. 17 times 17 is 289. 18 times 18 is 324. 17 and 18 are really close together. 17 and 18 work? Is 17 times 18 306? Yeah. So I've got 2 times x plus 18 and x minus 17. Negative 18, positive 17. Are those squares? No, they're not. They're not squares at all, but they allow me to arrive at my solutions. These are my squares. Those are my squares. Yeah. I mean 2 consecutive squares. What do you want? 9 and 4? So that would be 2 squared is 4, and 2 plus 1 is 3 squared is 9. See that? There you go. That's all right. So let's figure out what they are. What is negative 18 squared? 324. Now we'll plug in negative 18 here as well. What's negative 18 plus 1? Negative 17 squared? 289. So those are consecutive squares that add up to 613. Let's try plugging in the 17. What's 17 squared? Oh, that gives me the 289. What's 17 plus 1? Squared. Oh, so they ended up giving me the same result just in backwards order, and that's fine. So these are my 2 consecutive squares. I factored out the 2. Sure. Doesn't matter. Same answer. Flip it over. A rectangular garden has perimeter 288 feet. If the length is 4 more than twice the width, what are the dimensions of the garden? You see this problem, what's the first thing you're going to do? Draw a picture. Excellent. We draw the picture. We got width, length, and length. What's the formula for perimeter? Yeah, you add them all up. So 2 of the L's plus 2 of the W's is equal to 288. We got 2 variables. If you have 2 variables, you need 2 equations to solve it. So I got to come up with a second equation. What's another equation you got here? L is 2W plus 4, or 4 plus 2W. Either way is fine. So I have some information now that I can use. What is the long word that starts with an S that we're going to do right now in mathematics? Substitution. Take that. Whoop, goes in for the L. Sorry. 2 times 4 plus 2W plus 2W, 288. 8 plus 4W plus 2W is 288. 6W plus 8 is 288. 6W is 280. So W is 46.6 repeating. I've got the W. Have I answered the question? The question is the dimensions. What is the other dimension? How do I find my length? Plug the W in, yeah. Make a wrap out of it. There you go. Plug it in. 2 times 46.6 repeating plus 4 will give you 97.3 repeating. Awesome. Yo. Yeah, technically we should put feet. If you forget it on the test, I'm not going to mark it wrong. But if we prepare for the AP Calculus test in the future and you don't put it, you would be marked wrong. So you gotta have it for your tests. So. Not now, you're taking Precalculus. But if you would like to take the AP Calculus test when you're a senior, you can. Though you do not have to. You receive the college credit regardless of whether or not you take the test. Yeah, some people do. Yeah. Yep. Other schools have to take it in order to get the credit. You guys don't. Okay, here we go. Box with a square base and no top. Make my drawing. Box with a square base and no top is to be made from a piece of cardboard, a square piece of cardboard. There's my square piece of cardboard. I'm going to cut 4-inch squares from each corner and fold up the sides. So just to give you an idea of what's happening, I'm going to take these 4-inch squares. I'm going to cut them off and throw them away. Recycle them. And I'm going to fold along these marks and turn them up so that it will make that shape. Okay, let me grab it. Scratch sheet of paper. Anybody got a scratch sheet for me? Here we go. Pause the video. Okay, now you got it. Yeah. All right. So it says it holds 100 cubic inches. 100 cubic inches, is that area or volume? That's volume. Okay, so let's check and see what's going on here. If it's volume, I need all 3 dimensions. Now, your first dimension, I want to look at this height here. If you fold these up, okay, how high is it going to be? It's going to be 4. But the question is, what about the length and the width? I know I started out, you're right, it's a square. I know I started out with a square piece of cardboard that was X by X. If you cut 4 off of each corner, what are you going to be left with? X minus 8. If this whole distance here is X, and you cut 4 off there and 4 off there, it's going to leave you with X minus the 8 you trimmed off. So we have this dimension, X minus 8, and this dimension, X minus 8, it is the same. Can I now calculate the volume? Yeah, I got length times width times height is equal to 100. So 4 times X minus 8 times X minus 8 is equal to 100. This will now allow me to solve for X. Once I have X, will I know the size of the cardboard? And that's the question. What piece of cardboard is needed? What size? Yo. The height. Because when you fold it up, it's going to be 4 tall. Because that's your cut. Let's multiply. What's X times X? Times 4, 4X squared. Negative 8 times X plus negative 8 times X is how many? Negative 16x times 4 is negative 64x. Negative 8 times negative 8 times 4, 256 equals a hundo. It's quadratic. How do you solve quadratic? Set all equals 0, 4x squared minus 64x plus 156 equal to 0. Want a factor? Take it all 4. 4 times x squared minus 8x. Whoop, I'm sorry, 16x. And then what's 156 divided by 4? Does x squared minus 16x plus 39 factor? Yeah. What values work out? Two solutions. Let's check it out. Could your original piece of cardboard be 3 by 3? Why? Because you can't trim 4 off. Because you would end up with 3 minus 8, which is negative 5. That's absurd. Get rid of it. Let's try 13. Could it be 13 by 13? Yeah, because then it would give you 5 by 5 by 4, which works out. So excellent. We got a 13-inch by 13-inch. There's your labels. Piece of cake. Upside down. Ready? You guys keeping up? Quick pace because we got to get through it all. Okay, we got 2 more problems on the back after this, so we'll be good to go. Right triangle, hypotenuse, length 12.5. Draw my right triangle. And it says one leg is 8.5 inches longer than the other. What's the area? If I want to know the area, I have to find the length of the legs. Yeah, exactly. So give me an expression that relates, 8.5 units longer. Good. X and x plus 8.5. What's a formula that relates all those together? A squared plus b squared equals c squared. We will use the area formula later. But right now we turn to good old Pythagoras, and he says x squared plus x plus 8.5 squared is equal to 12.5 squared. X plus 8.5, quantity squared. Everybody's going to their calculators. Good for you. Okay. Square of the x, x squared. X times 8.5 plus x times 8.5. 17x. 8.5 times 8.5. 72.25 equals 12.5 squared. 156.25. 2x squared plus 17x. Subtract the 156.25 over. Negative 84. Very good. Got 3 options. What are they? Yeah, you could also graph it with your calculator and see where it crosses there. But if they said solve algebraically without, doing that, then you would have to turn to something else. Do you want to try to factor? All right, let's use the AC method. So if we multiply over by 2, we get x squared plus 17x minus 168. So I need x and x. What are 2 numbers that multiply to 168 and add to 17? Negative 168 and add to 17. I'm using the AC method and multiply it over. Ooh, Karina's done. Must have made it too easy. Either that or she's stinking genius. All right, just set it right there on the table. I'll get it. Thank you. You have a good day. All right. 7 and 24. Awesome. You got it. 7 and 24. So, okay, when I get the set, hey, if you can't do it with these numbers, then use the quadratic formula because that will never fail you. You always come up with an answer quadratic formula. Yeah. Yeah. That's correct because I'm not done. I got to stick the 2 back on. Look at the 2 back on, okay? Is there a common factor here? Yeah, so it's x plus 12. Is there a common factor here? So it's 2x minus 7. So your solutions are negative 12 and 3.5. So does the negative 12 work in the problem? No. So x is 3.5. And so that side's 3.5. What's that side? 12. Have I answered the question? The question is the area. Haley, you got a question. Area is 1/2 times the base, which is 12, times the height is 3.5. What's 1/2 of 12? 6 times 3.5 is 21. 21, we got inches, what? Squared. Bada bing, bada bam, bada boo, ski. We're going to get it. Flip it over. 2 more examples. Time flies when you're having fun. What was the answer? 21. A man walking away from a lamppost. We are going to snapshot the problem in time. He's 2 meters. The light is 6 meters. Okay? I accidentally wrote feet instead of meters here. And I left out an important part to the problem. The tips of the shadow, so his shadow and the light shadow are in the same spot. Okay, they meet at the same place. The ends of their shadows are right at the same spot. So if you look at the man's shadow, we'll say that that's his shadow. The shadow of the light pole brings you right there. What do we got going on here, folks? Yeah, what kind of triangles? Right triangles. What else? Tell me something else. These triangles are what? Starts with S. Sure, they're scaling. They're also similar. They're similar. Why are they similar? Same angles. Why are they the same angles? They share an angle here. What other angle do they have? Right angle. So 2 angles are same. If 2 angles are same, does the third angle have to be the same? So AAA says they must be similar. And if they're similar, then we know the sides are proportional. Yeah, all right. There we go. Awesome. You did take geometry. There we go. We are wondering the distance of the man from the light pole. So let's set this up. We're going to take the height and divide it by the shadow. What is his height? 2. What's his shadow? 5. What's the height of the lamppost? What's the length of the shadow of the light post? D plus 5. Multiply. 2D plus 10 equals 30. It says in the problem that the lamppost is 6 meters tall. 2D is equal to 20. 10 meters. Yep, piece of cake. Upside down. All right, and the last one. I did this problem 3 different ways last night. I'm going to show you the way I think is best. I might be missing something in terms of an easy way to do it, but I would challenge you to do it differently than I did. I've sent this off to a few math teachers and other people. It's interesting to see the work that they do. So if somebody else is watching this video, you know something I don't know, I apologize. I might be that dumb. So 2 flagpoles have a height of 9 and 13 feet. So I'm going to draw a flagpole, height of 9. Another one that's 13. We're going to assume that they're perpendicular to the ground. And the deal is that there's a rope attached to the top, and it connects to the base of the other one. So I've got a rope that looks like that, and we are wondering what is the height from the ground to where the ropes cross. Oh, man. Good thing I don't know who that is. We kick him out of class. Just say, you're gone. You're voted off. No, we knew what the poles were when we actually set them up because we ordered them. All right, so here's the deal. How can we solve a problem like that? Well, hey, first of all, watch this. What kind of angles are those? Vertical angles, opposite angles. Opposite angles are congruent. What do you call these? Alternate interior. And then you have another set of alternate interior. So the triangles are? No. Similar. I really don't like the way that the problem is set up to solve it with similar triangles. I think it actually takes longer. I'm going to show you what I think is a better and more efficient approach. Some of you are going to love it. Some of you are going to hate it. Okay? Here we go. Check this out. I am going to insert a coordinate plane. Whoop. Got to redo that one. Trust me, guys. This is really a good method, okay? Now, I'm going to insert a coordinate plane. And these two ropes, as they cross, I'm going to treat them like lines. And I'm going to find their intersection. When I find their intersection, the x value will tell me where it happens, but the y value will tell me how high above the ground it happens, won't it? Yeah. So watch me go here, okay? All right. What is this coordinate? 0, 9. Oh, we know the y-intercept of that one already. Ho, ho, ho. Do you know this coordinate? No. We'll call it d for some distance, and then the y value is 0. Do you know this coordinate right here? 0, 0. Oh, that was easy. Do you know this coordinate? D13. Very good. We're going to write two equations for lines. Y equals mx plus b. Line 1, line 2. And if you think this is the most difficult problem you see during the year, you're going to have to, well, dig in a little bit more because you're going to see ones a lot more difficult than this. No, you could drop the college credit, though. So, here we go. Line 1. Okay, let's look at this line that's headed downward. We need y equals mx plus b. Actually, let's start with the one that's going upward. What's the y-intercept of this one right here? 0. So all I need is the slope. How much do I go up to get to that point? 13. How much do I go over? D. So the slope is 13 over D. Very good. So I have y equals 13 over whatever distance that is times x plus b. What's the y-intercept again? 0. So we don't have any y-intercept. If that d bothers you, don't worry. It'll take care of itself. We do the next one. Y equals. Let's look at the slope. To get from this point down to there, how far do you drop? 9. So negative 9 over, what do we run? D. So negative 9 over D times X. Plus, what is the y-intercept? 9. I have two lines that I have written equations for. I will solve them and find the xy coordinate where the intersection is, and the y value will be how far off the ground it is. So, how do I solve for the intersection between these two lines if they're both written as y equals? Substitution. If they're both equal to y, then they're both equal to each other. Very simple. 13 over d times x should then equal negative 9 over d times x plus 9. Gather like terms on each side. Do they have common denominators? Isn't that nice? So add 9 over dx and you get 22 over dx equals 9. What am I trying to solve for? We want to solve for x, okay? We want to know the x coordinate. So to get rid of this fraction, I multiply by the reciprocal times d over 22 times d over 22. I get x is equal to 9d over 22. Don't worry about the d, okay? Now, did I find the y value? I haven't found it yet. How would I find the y value now that I know the x value? Plug it in for x. So y equals 13 over d times, what is the x value? 9d over 22. Oh, what happens? The d's cancel. Isn't that beautiful? 13 times 9 is 117 over 22. So, how far above the ground? 117 over 22 feet, which is approximately, somebody want to divide that for me? 5.32 feet. Look at that. That was the last problem. Isn't that awesome? Now, raise your hand if you think that if you saw one of these problems on the test, it might give you a run for your money. Then what you need to do is this. Number one, you need to do the worksheet. If you do not keep up with your homework, you have a potential to literally get a 5 out of 30 on this next test. So, focus on the homework. Second of all, watch the video again if you didn't get one of the problems. I'm going to upload it right after this class. And third of all, ask questions in class when you have them. You will be given time to work probably on Monday next week. We're going to continue notes on Thursday and Friday to finish up our topics, and we'll get going. I have your assignment. Goodbye, YouTube Nation. Good luck.